All right, today in this video we're going to talk about the substitution method, and you can get those steps. I'm going to go through the steps, but you can get the detail and steps from the PowerPoint. So, in order to very first do these substitution problems, what we're going to want to do, step one, is we're going to want to isolate one variable of one equation. And it doesn't matter which variable you isolate, or you might notice that actually in this system of two equations, one of the variables is already isolated. So actually we don't have to even do step one right here. It's already done for us. The second step is we're going to take that expression and we're going to substitute it in for that variable. So since x is equal to 2y minus 2, they're equal to each other. Essentially, they're substitutes of each other. If you think about me, if I was absent for whatever reason, if I had to get a sub, they would be my equal, wouldn't they? So they would fill in for me. So what we're going to do is the substitution part, we're going to take this expression 2y minus 2 and we're going to plug it into the first equation. So we have 2y minus 2 minus y equals 4. So you're going to substitute for one variable. So what we did is we just substituted that whole thing in for the x right here. Okay? Does that make sense so far? So far, so good? And then after we've done that substitution, we're going to solve for the remaining variable. So that's what we're going to do here. Second, we're going to solve. So we want to solve for y. What would we do to solve for y? 2y, we want to combine our like terms. What's 2y minus y? Y minus 2, right? That minus 2 stays, equals 4. How will I get y by itself? What should I do next? Add 2 to both sides, and I get y equals 6. Am I done? Well, I have y, so once I solve for y, what should I do to find x? Yeah, we want to plug, oops, that was step 3, sorry. Plug in y to find x. And that could be or vice versa. If you solved for x, you would be plugging it in to find y. And if I do that to both, I call that a check. Check number 1, I'm taking y equals 6. I'm going to plug it into both. Check number 2, I'm going to plug it into the second one. So I'm going to plug it into both. So check 1, check 2. So in the first equation, I'm plugging in 6 for y. So I have x minus 6 equals 4. And I want to solve for x. What should I do to solve for x? Yes, add 6 to both sides. I get x equals 10. Now, if I plug the same y equals 6 in here and I get x equals 10, then I know it's right because I got the same 10 in both. So that's why I have to do it in both equations. So now I have 2 times 6 minus 2. X, that's my second equation. X equals 12 minus 2, x equals 10. So what is my solution then? Solution is 10, 6. So we'll state solution as an ordered pair. And my steps are going to be very similar to the one on the PowerPoint, but might be slightly different, right? So that's done. We have check 1, we got 10 in both, so that checked out, so we can feel pretty confident that this is our solution here as an ordered pair. Okay, for the next one, neither equation has a y by itself. So what do you think I should do to get y or I mean to actually, it doesn't have to be y even. What should I do? I want to take one of the equations and isolate one variable. Which equation would be easiest to isolate a variable in? Yeah, the first one. And which variable would you want to isolate there? So 1, we're going to take 3x minus y equals 17. Oops, that's a 17. And we're going to isolate y. So that means solve for y. Same thing as solve for y. So what should I do first to get y by itself? Subtract 3x from both sides. And I don't forget this negative. Now, if that's positive, then it goes away. But as a negative, we have to bring the negative with the y. Negative 3x plus 17. Is y currently by itself? What do you need to do to isolate y? By, yep, divide everything by -1. What is that going to do to the signs? It's going to change them to the opposite. So we get a positive 3 because a negative divided by a negative is a positive. We get a negative 17 because positive 17 divided by -1 is negative 17. So now we've isolated, and we're going to plug this in. Step 2 is we're going to plug in for y. This whole expression gets plugged in for y into the second equation. So we have 5x plus 3 times this whole thing, 3x minus 17, is equal to 5. So substitute for y, and then we're going to solve for x. Because the whole point is we wanted to get an equation in one variable. And do you notice that the equation we now have, it's like a Math 60 equation. It's in one variable. What will I need to do first to solve for x here? Yes, distributive property. I love that. Good use of the vocabulary. 5x plus, what do you get when you distribute? What is it? 51. Good. 51 equals 5. Now what do? I add the x's because they have the same signs, right? They're both positive. A 14x, is that right? And then I'm going to add 51 to both sides equals 56. Good. And what should I do next? Divide both sides by 14, and we get x equals what? X equals 4. Is that right? You said 4? You tried it on the calculator? X equals 4. Am I done? Did I solve? I'm finished, right? I just walk away? What should I do next? Now that I have x, I have to find y. So I'm going to give myself a little bit more space here. Okay? I want that's going to count as a check. Check number 1 and check number 2. If I plug in x is 4 and solve for y, I'm going to have my y value. Okay, so I'm going to plug in x equals 4. 3 times 4, I'm writing kind of small, minus y equals 17. I want to give myself space. 12 minus y equals 17. Subtract 12. Negative y equals 5. So what does positive y equal? Negative 5. Okay, let's see if we get the same thing when we plug in x equals 4 into the second equation. That's why I have check number 2. 5 times 4 plus 3y equals 5. I want to see if I can get that same negative 5. So I have 20 plus 3y equals 5. I subtract 20. I get 3y equals negative 15. So what would y equal? Negative 5, because we would divide both sides by 3, right? Okay, so what is our solution? Our final step, we want to state the solution. Who can tell me what the solution is to this problem? 4, negative 5. Very good. Okay, that's our answer. And it checked out in both because when we plugged in x, we got the same exact y, so we know that that's the point of intersection of those two lines. Of course, if you're at home, you can always use Desmos or your graphing calculator to plug these in. These are harder to plug into the graphing calculator, but if you use Desmos.com, you can literally type that in exactly as you see it, and you should be able to see that point of intersection. So that's another way just to keep practicing the graphing. Okay, so we have two special cases. When equation turns out to be false, not equal, the system is blank. For example, so what if I were to go about solving and all of a sudden I have no more variables and I'm left with something like -5 equals +5? Is that a true statement or a false statement? That's false, right? Is false. Do you know what would be going on if we don't have a solution because we get a false solution, we get a false statement? What could be going on there? Do you think about the lines? Oh, the lines would be parallel. This would mean parallel lines. And do we remember what that system is called when you have parallel lines? Inconsistent. Inconsistent. And that's the same thing that happened in Math 60. Sometimes you solved equations and they didn't have a solution. And it's the same thing when you have two parallel lines. They're never going to cross. They have the same slope, and you'll end up with a false statement. Now, sometimes when you solve an equation, it turns out that it's always true. For example, something like this, 5 equals 5 is a true statement, or 0 equals 0, or even x equals x. Okay, x equals x could be another situation. Okay, when an equation turns out to always be true, the system is what? It's consistent. And consistent means that they're the same lines. And the same lines intersect infinitely because they're one on top of the other, right? So since they're exactly the same, they're going to intersect themselves constantly. Or no, that's not called consistent, you guys. Consistent has one. Sorry, what's it called? Dependent. Why didn't you correct me? Dependent. It's dependent. It's not consistent though, right? The PowerPoint doesn't say consistent, does it? Consistent means there's one point of intersection. Sorry, I was thinking the opposite of this. Okay, let's go ahead and turn the page. We're going to actually stop the video and do a new video all about word problems.